Today, we're going to pull back the curtain on a couple of recent and honestly pretty scary attacks. These aren't your typical viruses. They go after the very heart of how modern software gets made. Let's dive in. When you think about it, just about every piece of software we use isn't built from the ground up anymore. Developers grab these pre-made open source building blocks, we call them packages, to build amazing things super fast. And the whole system, the entire thing, it works because of one simple ingredient: trust. Developers have to trust that those building blocks are safe. So what happens when the very foundations you're building on are rotten? What if the code you're pulling in has a secret, malicious purpose? Well, that's what a software supply chain attack is all about, and we're going to look at two wild examples that show just how bad it can get. Okay, first up, we're looking at the NuGet repository. Think of it as a huge library of code for developers using Microsoft's .NET framework. And this is where a bad actor launched a pretty slick, multi-stage attack that had ASP.NET web applications right in its crosshairs. And get this, before it was finally caught and shut down, this thing had some serious reach, over 4,500 downloads. That means thousands of potential infections, not just on some developer's laptop, but baked directly into the applications they were shipping to the public. This whole operation wasn't the work of just one rogue package. No, it was a coordinated effort by these four, all pushed out by a single user. They were designed to work together, like a team, each with its own nasty little job to do in a much bigger, more sinister plan. The attack was actually pretty clever. It happened in two stages. First, the encrypto package was the Scout, the one that got its foot in the door. It set up a local proxy, which is basically a secret tunnel connecting the application straight back to the attacker's server. And then, once that tunnel was open, the other three packages got to work, using it to siphon off user data and even sneak in new rules that gave the attackers full admin access. And this quote from a security researcher really hits the nail on the head. The attackers weren't trying to hack the developer's computer, they were playing the long game. By poisoning the building blocks, they guaranteed their malware was built right into the final product. It was a Trojan horse waiting to strike once the app went live. All right, let's shift gears to our second case. This one takes us from NuGet to NPM, which is the absolute biggest software registry in the world, this time for JavaScript. And this attack, it had a totally different target, and as you'll see, a much, much wider net. So, unlike that four-part scheme we just saw, this attack was all packed into one single cleverly named package, Ambar-SRC. It was a true wolf in sheep's clothing, hiding all of its malicious power inside one component that looked totally harmless. Now, check out this number. Over 50,000 downloads. 50,000. That's more than 10 times the reach of the NuGet attack. This wasn't some small-time threat. This was a massive campaign targeting the huge global community of JavaScript developers. And here's why it was so dangerous. This one package was like a Swiss Army knife for hacking. As soon as it was installed, it would check what operating system the developer was using. Windows, Linux, Mac OS, it didn't matter. And then it would download a custom-built payload just for that system. We're talking about tools that could give an attacker a direct remote shell, basically handing them the keys to the machine, or sophisticated agents designed to steal passwords and hunt for sensitive data. So we've looked at two different attacks, two different platforms, two different goals. What's the big takeaway here? Well, when you put it all together, the conclusion is pretty clear, and frankly, it's alarming. Think about it. Even though their goals were different, one was after the app, the other was after the developer, their strategy was exactly the same. Both attacks weaponized the one thing that makes the entire open source world go round: trust. They turned a system built for collaboration and sharing into a delivery system for malware. Just let that sink in for a minute. This is a warning from the security firm Tenable about that Amber SRC package. It couldn't be more blunt. If this code is on your machine, that system is done. It's fully compromised. This isn't a bug you can just patch or a file you can delete. The moment it runs, you have to assume an attacker owns everything. And all of this leaves us wrestling with a really tough question. In this world where our software is assembled from pieces from all over the globe, often from anonymous contributors, who's actually responsible for making sure it's safe? Is it the platforms like NuGet and NPM? Is it the developer who uses the code? Or is it the person who ends up using the final app? These attacks prove there are no easy answers.